All right, everyone. This is the last unit of Algebra, Chapter 11, Radicals. This will consist of 3 short lessons, and we will have 1 quiz to wrap everything up. So, a radical, for those of you who are not familiar with that term, is basically the square root symbol. The square root symbol, another name for that is called the radical. This thing right here. Okay? That's the radical. The number under the radical is called the radicand. All right? Just in case you see that term somewhere, that's the radicand. Now, there are 3 rules for radicals in which we must follow. And if we are not following these rules, then we must simplify the radicals until the rules are met. Okay, so for example, 1, the first rule, the radicand has no perfect square factors. So basically, this entire lesson will focus on rule number 1, this first lesson. So the square root of 24 is not simplified. Okay, and we'll see how to simplify it on the next slide. But just keep in mind, this rule number 1 is the rule that this entire first lesson will encompass. Rule number 2, you're not allowed to have fractions underneath a radical. So this must be simplified, and we will learn how to simplify that as well. Finally, rule number 3, you're not allowed to have a radical in the denominator of a fraction. Okay, see how the radical's below the bar? Here's the bar right here, the fraction bar, and we have a radical below it. That's not allowed in math. So we're going to have to figure out how to simplify that as well. And that'll be in the next lesson. So the first thing we should get good at is identifying what a perfect square is. A perfect square is a number that is basically square rootable. So like 0 is technically a perfect square because if you square root 0, you get 0. So a number that you could take the square root of and get a whole number is a perfect square. So basically, to get the perfect squares, just take all your numbers and start squaring them. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25. These are all the perfect squares. Because if you square rooted any of them, if you square root 25, you get 5 back, right? If you square root 16, you get 4 back. If you square root 9, you get 3 back. So these are all the perfect squares, and you should get very good at knowing this list of numbers. You should have it memorized. 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, I believe, and 15 squared is 225. You should know up to at least 12 squared by heart. Okay, the rest you could use a calculator for. Okay. One other important note to keep in mind. Whenever you take a square root of a number, like square root of 25, that equals 5, right? Technically, it also equals negative 5. Yeah, so like the way we write that, square root of 25, we would write plus or minus 5. You write a symbol, it's called a plus minus symbol. Because if you do 5 squared, you get 25, right? If you do negative 5 squared, you also get 25. So 25 technically has 2 square roots. It's got positive 5 and negative 5. All right, that's just something to keep in mind. All right, so how do we actually simplify? So back to our example on slide 1, we had the square root of 24, right? You have to recognize that 24 is a number that has factors that are smaller than it that could be square rootable. So like 24 can be written as 4 times 6, right? Well, 4 is square rootable. So here's what you do. You rewrite 24 as its 2 smaller factors, one of which will be square rootable, aka a perfect square, right? So I'm rewriting square root of 24 as square root of 4 times 6. Nothing has changed. All I did was rewrite the 24 as 4 times 6. I didn't change or do any math to it. I'm just rewriting it in another format. 24, instead of writing 24, just write 4 times 6. Now, we know that the square root of 4 is 2. Square root of 4 is 2. Square root of 6 we cannot do. So we leave the square root of 6 as is, and we write the 2 outside of the radical, because the square root of 4 simplifies into a 2. Another way of doing it is we could rewrite, instead of writing square root of 4 times 6, we could rewrite this as square root of 4 times square root of 6. Like, that's technically the correct step to write. And then the square root of 4 becomes a 2. The square root of 6 just stays square root of 6. Because you cannot square root 6. It's not a perfect square. So the square root of 24 simplifies into 2 root 6. Let's try another one, and then we'll go to the next video. Square root of 20. So think of all the factors that go into 20. Well, 1 times 20, 2 times 10, 4 times 5. Find the one that has a perfect square in it. This one right here. So square root of 20 is really square root of 4 times 5. And then the square root of 4 times the square root of 5. Well, the square root of 4 is just 2. Square root of 5 does not change because it's not square rootable. And that's it. That's your answer. Square root of 20 becomes 2 root 5. That's how you say it, 2 root 5. Or you could say 2 radical 5. All right, see you in the next